All right, so today I've assigned to you a scientific notation worksheet, and I know we went over it briefly in the slides. I just wanted to go through each type of problem you're going to see just to kind of give everyone a refresher. So if you'll watch this video first, I think it'll help you a lot when you go to do the worksheet. So the first one says, convert the following to scientific notation and then round the answer to 2 significant digits. So I have 2 things to do, right? I need to get this into scientific notation, and then I need to round the answer. Now, how many significant digits you round to depends on what you're told to do. So whatever it says to do that. So you can do it in either order. You can round first and then do the scientific notation, or you can do it into scientific notation and then round. I tend to like to do it that way, but it really doesn't matter at all, but I'm going to do it that way. So the first thing I need to do is get this into scientific notation, right? So when I look at this number, the decimal is right here, right? And I need to move it until I have a number between 1 and 10. So I'm going to move it this way. So it's going to be 1 spot, 2 spots, 3 spots, 4 spots, right? So my new number becomes 1.2349 times 10. And remember that 4 we just counted is our exponent. And since this was a number greater than 1, the exponent is positive. So 1.2349 times 10 to the 4th, right? So that's step 1, converted to scientific notation. Now I need to round to my 2 significant digits. So I just count from the left, right? 1, 2. That 2 is the second significant digit. The 3 is going to tell it what to do. So that becomes, the 3 tells the 2 you're going to just stay the same. And then since it's after the decimal, everything else just goes away, right? That's why I'd like to do it, do the rounding after I convert to scientific notation, because then whatever I'm rounding out can just go away because it's always going to be after the decimal. Well, not, yeah, always. One. So it becomes 1.2 times 10 to the 4th. All right, so let's look at this one now. Do the same thing. We're going to convert to scientific notation. There's my decimal right there. I'm going to move it 1 spot, 2 spots, 3 spots, 4 spots, 5 spots, right? And it becomes 6.7590 times 10. And it's the 5, right? Because that's how many times I move my decimal. But this time I started with a number less than 1. So my decimal becomes a -5, right? If I start with a number greater than 1, my decimal is positive. If I start with a number less than 1, my decimal is negative. Now I have to round. So the 6, the 7 is the second significant digit. I'm going to round to that one, or round that one, and I'm going to look at the number behind it to see what to do. The number is 5. A 5 tells it to go up. So it becomes 6.8. Get rid of the rest of those, right? 6.8 times 10 to the -5th. Now we're going to do the opposite. We're going to convert from scientific numbers back to a normal or real number. Real number probably isn't the best term because that has a very specific scientific meaning, but back to a normal number. Round the answer to 2 significant digits. So again, I'm going to round to 2. And this time I'm going to round before I convert. You can round after. Again, it does not really matter. So to 2. So I'm rounding this number, right? And the 4 is going to tell it to stay the same. So it becomes 1 point, it just becomes 1.2. The exponent is going to tell me how many times to move my decimal. It's a positive exponent, so my number is going to get bigger, right? Because I'm basically times 1,000. I move it 3 times, so it's going to be 1. Write it down here. 1, 2, 0, 0. You can see my decimal was here. I moved it 1, 2, 3 times to put it right there. All right. Okay, and then the last one is this one. Again, I'm going to round first just because that's the way I like to do it. If you want to round later, that's fine. I'm going to round that one using the 8. The 8 is going to tell it to get bigger, right? So it becomes an 8. Those 2 disappear. So now I'm just dealing with 5.8 times 10 to the negative 4. Now it's negative 4. So now you're dividing by 10,000. So this number is going to get smaller by 4 decimal places, right? So I need to move it 4 this way to the left. So I'm going to write the number out and then show you. So remember, my decimal was right here between the 5 and the 8. So I moved it 1, 2, 3, 4 to get it there. So 0.0058. Okay, the next one is solve the following addition and subtraction problems. So remember, when we're doing addition and subtracting, the exponents have to be the same. I gave you for bell work some addition and subtraction where those were already the same, so you didn't have to worry about it, but we always have to make them the same. It doesn't matter which one you change. You can change either one. I'm going to, in this one, change the second one, right? So I'm going to have 1.3 times 10 to the negative 4th plus, now I'm going to change this to negative 4. So if I go from negative 5, which is 1/100,000th, to negative 4, which is 1/10,000th, this number got bigger, so this number has to get smaller. So it becomes 0.24 times 10 to the negative 4th. And what you're saying, I'm going to do a kind of a sidelight over here. This has nothing to do with the problem other than what you're saying is 2.4 times 10 to the negative 5th is equal to 0.24 times 10 to the negative 4th. That's why you can do this. They're equal to, so 2.4 divided by 100,000 is equal to 0.24 divided by 10,000, right? So what you're doing when you're making these is if this number gets bigger, this number has to get smaller. If it went the other way, if you're going this way, if this number gets smaller, this number has to get bigger. So then all you have to do is do the math with the first part. So it becomes 1.3 plus 0.24 equals 1.54 times, and then you just keep that exponent that you determined that you made the same, times 10 to the negative 4, right? Okay, now let's do a subtraction. So I'm going to change this one again. So I'm going to change that one. So it's going to become 5.7 times 10 to the 5th minus, now this time I'm going to change the 10.6 to 10.5. So that got smaller, right? It went from million to 100,000. So if this got smaller, this has to get bigger, right? So 6.1 or 61. I made that bigger by 1 decimal times 10 to the 5th, because that got smaller by 1 decimal position. All right, so 61 times 10 to the 5th is equal to 6.1 times 10 to the 6th. Now, since it's subtraction, of course, it's weird. Minus 61 equals negative, right? Because I'm smaller number minus a bigger number, it has to be negative 55.3 times 10 to the 5th. And you can see I'm not quite done yet, right? Because this is no longer in correct scientific notation. It's not between 1 and 10. So I need to move the decimal one more time back this way till it's 5.53, making that number smaller. So my exponent has to get bigger, right? So you have to convert it back into scientific notation if you come up with an answer that is not in scientific. Oh, I'm sorry. That's a negative 5.53, right? So yes, your answers can come out negative on these subtraction ones. There's nothing wrong with that. Okay, now let's move on to multiplication and division. Remember, multiplication and division, we don't have to make the exponents the same. We're going to do something else with them, right? So what we're going to do is we're going to take the 3.3 times the 2.6, and it's going to be times 10 to the, it's multiplication. So 6 plus the minus 2, right? Oops, that's the exponent. I'm sorry. So 3.3 times 3.3 times 2.6 is 8.58 times 10 to the exponent. So 6 plus a minus 2 is 4, right? 6 plus minus 2 is 4, so 10 to the 4th. And then the last one is the 6.8 divided by 4.5. 6.8 times 10 to the negative 8 divided by 4.5 times 10 to the negative 3. So let's look at that one. We're going to do the math, right? 6.8 divided by 4.5 times 10. An exponent ahead of time this time. And this time it's going to be minus since it's divided. So minus 8 minus. So notice when we multiplied, we added the exponents. When we divide, we subtract the exponents. Minus a minus 3. All right. So 6.8 divided by 4.5 is 1.51. Yes, if you do it on your calculator, it's 1.511 repeating. I'm just rounding it to that 1 times 10 to the minus 8 minus a minus 3. So minus a minus is a plus. So minus 8 plus 3 would be minus 5. Oops. Right. So I hope this helped you. I think it covered everything you need to be able to do. Remember to do, if you get ones like this, you need to get them back into scientific notation. Just read the instructions and see what you're asked to do on the rest, whether you need to round or not. I think you don't have to round everything, just the first couple sections.